Hey everybody, and thanks for watching my videos. I hope you've taken the opportunity to subscribe to my channel, and so whenever these new videos do come out, you get the added context to your database, basically. We're going to cover Chapter 3 this time, and it's out of the 5th edition of Measurement and Evaluation in Human Performance by Morrow Jr. I hope you've taken the time to watch the first two videos out of Chapters 1 and Chapter 2. Basically, they help set the context up for this video, and basically we're getting into the work here. Now we're going to go into where the idea of stats, this being a stats class and this not being a stats class, those lines start to blur. So if there was any video that you may need the opportunity to stop, work on, read, and probably rewatch, these next two videos are probably going to be that type of video, mainly because everything else that we cover in the rest of the book is going to be predicated upon your knowledge on this chapter. So I hope you take the opportunity to read. Definitely reading the chapter is going to help. And unfortunately, sometimes books are inaccurate. So there are some, and we'll get into it in the second chapter, but we're going to make sure that we cover all the bases and then we practice some of those bases. So as always, I try adding context to these videos, and right here you're going to see the objectives that we're going to cover. Basically, we're going to cover scales of measurement, summation notation, reporting data, and central tendency in this video, where we'll cover distribution shapes, variability, standard scores, and the summary in the next one. Basically, like I said, a lot of both of these videos are going to cover a lot of context and a lot of topics that we're going to build on those skills in the next several chapters and throughout the rest of the book. These would be the videos that I need to spend extra time on, extra notes, and trying to make sure I understand the material best enough to present it to you. Let's get started. Here's the terms that we're going to go over in this chapter, so make sure you take the time to write these down, try to find the definitions for them. They're all out of the textbook, so obviously take some time. If you need to, pause it right now and write this term chart down. I'm trying to figure out how I can upload my PowerPoints without using the email system, because 98% of you, and that's a fictitious percentage, don't check your email. So we need to find another way to make sure we have a better means of communication. Here's the terms for this chapter. And here's the math we're going to cover. So getting some practice in, we're going to cover a lot of this in the second video, but here's the introductory slide for all of that. Please take the time to read this chapter. I really cannot stress that enough. So here's the philosophical statement of this chapter. Who needs to know descriptive statistics? Who needs to know the stats? You do. And as easily put, you're studying to be a kinesiologist. So you have an interest in teaching health or healthier lifestyles or training people to do so, and that pretty much sums up who you are. You're a biomathematician. We take data from bench press maxes or sub maxes, and we predict where they're going, how they're going to do it, and we do that with the help of descriptive statistics. So basically, what do these numbers mean? So when you look at a chart and it says you have a body fat percentage of obesity, what does that mean? And we have to relate to your client, patient, or customer and describe what that means. So if you have an obese person, that means they're at higher risk for CHDs. So that's where descriptive statistics really start helping us, giving that factual data and be able to, represent to the client and say, hey, this is where we're at. You're either a plus athlete, or you're a person who needs to really get started and change some lifestyles, and this is how we do that. Scales of measurement. So again, in the earlier chapters we cover what measurement is, and here we go again, the act of assessing generally a number. So what are areas that you think that can be measured? So we have height, weight, helps us measure BMI, girth measurements, distance, time, gas mileage, why you're always broke. These are all areas that we can measure. Now, what do these numbers mean? So what are all these measurements? What does that mean to you? And that's where we start talking about context. What is context? Context is probably one of the most important things that we can generalize over. So it focuses on the direction of the conversation or the lecture. So it's where we develop our basis of thesis. And I know it sounds a little over my head too, but basically the context is, does the waistband fit on a pair of blue jeans the same way that it does a pair of jogging pants? And obviously you have your own answer on that, but that's your context, and that's how we describe these measurements. So under scales of measurement, there are several definitions we really need to cover. The first one is going to be nominal, and just as the slide says, is generally naming or classifying. So when you look at something that's like or generally mutual, you think of football players, or I'm going to use football players as an example, but calling a team of football players is kind of broad. So you're using a broad brush to paint that description. These are more qualitative descriptions, if you remember that in the previous chapter. So looking at football again, we're defining what QB is differently from a tackle, and that's more focused in the nominal description. So we're basically starting to classify them in groups. You have your ability groups too. So back in the military, and I'll have a lot of examples on this about ability groups, is where when we have our 2-mile PT test, the faster group of people will be considered the A group. Then you have your medium speed of people, and we'll put them in the B group. And then you have your slow group, which would be the D or C group, depending on how many people fit in that category. So there's multiple different ways to nominally classify people, as in male and female. So obviously that's a very dichotomous way of doing it. So it's not a numerical ranking system. So it's basically you fit a criteria for a certain area, and we'll just put you in that. So opposite of nominal, we have ordinal. It's not exactly a complete opposite. I just use that to lead that into here. But basically, ordinal is now when we're talking about that numerical ranking system. It's more quantitative as opposed to qualitative. And now we're looking at that rank. So if you ain't first, you're last by Reese Bobby. I mean, now again, in context, what does that mean? But now we're using the football analogy again. So now we're quantifying which string quarterback you are. So first string, second string, third string, travel team, away team, whatever. So now it's more ordinal. Now you have a ranking system. You're now in first place, or you're in last place. That's the way how ordinal works. And so now we have continuous. That's the last of the 3 terms about scales of measurement. Continuous could be broken down into 2 different ideas. So we have continuous, which is slightly never-ending, and I'll explain that here in a minute. But it just keeps on going. So we have 2 different types of continuous measurement, where you have continuous or interval or ratio. Interval, you're looking at a common type measurement, apples to apples. So 0 is arbitrary. It's just a continuous number. Thinking of playing a video game, an online video game, and you've played it for 6 years, and you think you're really great at it, but then you look at your ranking and it says you are the 176,000th person in rank. So you're literally in a certain bracket of people there. So that would be considered your interval. 0 degrees Celsius, just the freezing point of water. It obviously goes below 0. Ratio, right? Now 0 has a meaning. How far away are we from 0? And we'll talk about 1 plus 2 standard deviations from 0. So now 0 has a number. Ratio, also we can compare apples to oranges or apples to potatoes. So what's our fruit-veggie ratio going on right now? If you see the example I have on the slide, BMI is measured in kilograms and mass or meter squared. So that's 2 different units of measurement. And how do we compare those 2? This is how we compare those 2. So this is how units or conversions exist, is via ratios. Moving on to summation notation. Now, what is summation notation? It's basically a shorthand for a note-taking system. Some people measure, in the clinical world, we measure prostate numbers either as PG1s, prostaglandin receptor 1, or PSH. Just depends on the context, if you're looking at an overall number versus a single number. So basically it's just shorthand. So you look at kilogram is abbreviated as kg, pounds abbreviated as lb. This can be vast and complex, again talking about context that you're trying to portray. But for the purposes of this book and this class, you're going to kind of remember some of these. Capital N and a little n are different. The capital N, measure of case or number of cases. So if you have like 300 people at bat, that would be 300. But also at the same time, little n kind of means the same as well. So we'll explain that in a minute. It's just more of a mathematical numerical process that we use with the little n. The capital X or X, any measurement, it's arbitrary. So when you go back to your notes in algebra, everything had an X next to it. Basically, you're trying to compare X's and Y's and Z's and whatever number that's there. So it's literally, now you got 300 people at bat, any measurement. So we're talking about how many people hit home runs. So there. E sigma, the sum of. So we'll explain, and you can see at the bottom of the chart there, sum of X. That's it's a way for us to have a shorthand to say that instead of writing it all out. Little n, nth, number of observations. The book is very confusing about that ideal. I think the book says something about the last observation. It's not the last observation. It's kind of like how capital N sounds like the number of cases. So that's again how we're going to use it mathematically. So you look at the sum of x squared versus the sum of x's squared. So now that's two totally different beasts slay. So here's our first example of this chapter. So you're going to look at the numbers 1, 2, 2, 3, 3. Now here I want you to pause the video or stop it or whatever, and I want you to try finding the sum of x squared or the sum of x's squared. I'll have the answer basically posted in the description of this video, but you can also find it in the book. So if you're having a really hard time, use the book. The next slide will actually cover how to tackle both of these problems. And so here's the answer and how we're going to take the sum of x and sum of x's squared. The sum of x, right? So the sum of x is squared. You're looking at the actual sum of x, and then you're going to square that number. That's the reason why you have an answer of 121. So you're going to add the 1, the plus 2, the plus 2, the plus 3, the plus 3. You're going to square that number. Then you're going to look at the sum of x squared, and now you're going to actually square each of the numbers before adding them up. So that's how, again, two different beasts to slay. This is a good slide to see the disparity of the two. So you need to make sure you track your numbers and make sure you are reading the questions the right way. So again, sum of x and the sum of x squared are two different answers that we're looking for. And here's the second example out of the book, the 3 all the way to 5. And here I want you to find the sum of x squared, the sum of x's squared. And then I want you to start thinking of variance. So that's what the s squared means. If you go back to the mathematical chart and at the very beginning, you'll see the s squared, and that's what it equals. Basically, now you have enough information to find that answer. The answers are on YouTube, again, and they're also in the book. So make sure you take the time. If you have problems with it, again, ask questions. Throw a question at the bottom of the video, at the comments. But here we're going to start moving some numbers around and starting to put things together mathematically versus what we do as exercise scientists. All right, everybody, I think that's going to be enough for this video. Again, take the opportunity to, one, review the video, rewatch it a couple times, take the time to read the chapter. We do have quizzes and exams that coincide this course material, so make sure you read the chapter. You may not have a full understanding the first time you read it. You may not have a full understanding the second time you read it. So the best way to do this is just to approach it in a very pragmatic style. So read it just to read it the first time, read it to interpret the second time, and read it to memorize the third time. So if you're ever having trouble with any other class that has a lot of wordy material, that's really the best way to ingest it. Take some time, go over the definitions. You can't speak the language if you don't know the terms. Hats off to Dr. Scheidt for letting me use that one, but the that's the best way to really get the context of this textbook and to be able to use this textbook to, one, make a grade, and two, it'll help you in your career. So, you know, this is a lot of data that I use personally almost on a daily basis. So you can't sit there and say we don't use test and measurements, because we do. You know, I'm a kinesiologist, I'm an exercise scientist, and I do it daily. So if you haven't subscribed to the channel yet, this is how you do it. You go to YouTube. Hopefully you have your free Gmail account, because YouTube has been bought out by Gmail, or Google, so to speak. And again, it's free, so don't have a little conniption if I ask you to have to, you know, sign up for a free Gmail account, but you need to have one to have a YouTube account. So you gotta have your YouTube account to go here to click subscribe, and from subscribe, you should see a little bell icon appear, and when you click on that bell icon, that's when and only when you have a full subscription to the channel. So when I produce the next video, you get a notification saying, hey, Andy made a video, you should probably watch it, it's pretty cool. So that's how you subscribe to a YouTube channel.